Okay, we'll assemble Scuttle version 2.4 today. And basically it's going to consist of making these two wheel brackets with their respective numbers and then separate assemblies for these two guys. So I'm going to pull out the box of brackets of hardware. And then you're going to have two of those. These corner brackets made of aluminum use the drop-in style nuts. So, and they use the M6 screws. I'll just pour them all out. And they don't need any washers for these. So you can individually take the brackets and get a nut ready. This is called a drop-in nut because it can drop in like that. And each one will be populated with two drop-in nuts. And the other M6 screws and their respective extrusion nuts will go into the wheel brackets. The wheel brackets use the slide-in nuts rather than the drop-in nuts. Okay, then we're going to just orient these so that they're going to mate and make a rectangle with the other extrusions. You want to have those hanging down low enough that they drop in past. Don't fasten them all the way because then you can't clear this lip. Then I just tighten them enough so that they stay steady. And you don't have to worry about the precise spacing of the 90-degree bracket yet. Really putting no torque. I just bring it down to where it touches, and you should keep the weight of the screw down to make sure gravity lets the nut hang below the channel in the extrusion and it gives it clearance to turn. You could look closely at that when you have your kit, but basically it's the rotation of this that needs to happen. So those are front and back extrusions, and we'll have this R means right hand, a right hand wheel bracket. They also use the same screws for all except for two. So, and then the nut, this is what the slide-in nut looks like. So I get the slide-in nut on there. I'll do this one by pre-prepping, and I'll do the other one by sliding them in ahead of time. Depends on your preference. And the smaller face of this nut needs to contact the plastic. The broad face is exposed towards the center line. So this one, at this time, when you assemble it, it doesn't matter the orientation of your extrusion since everything's symmetric. You just have to know that you're sliding these in on opposite sides of one another. So that will go in. Doesn't matter here or here right now, but it will just matter once you get a little further along. I think it's best to get the wheel equipment populated on here first. So I'm just gonna pause at this stage and switch to my wheel, and I'll remember the most optimal way once I get a little further. If your screwdriver is magnetic, then you can pull that, and you might. So you'll need to see the hole in the nut. So if you tap the extrusion, you'll walk the nut down to where it needs to be. So now I can see the threads. Drop that in, and I'm gonna assemble this all with the short, the same length screws, and replace 2 when it's all said and done. The 2 that are longer will mate to this power adapter, this 5-volt adapter. Okay, so once again, they're just snug enough to not go anywhere, but they're not tightened yet. Now let's get into the wheel assembly. So wheel assembly consists of the M8 screw and the wheels. One washer stays on. This bolt. I recommend having a dish or something so your screws don't, your hardware doesn't roll around as you get things put together, especially if you have a smaller table and you're bumping more. So one washer stays on, and that passes through the wheel from the outside. And also I'm going to test that my holes have a nice fitment on this. You should be able to push it in, and there shouldn't be clearance, but there also shouldn't be, well, it shouldn't be this hard like that. So we're going to do a little work on this bracket before we do the assembly of this bracket. Otherwise the clearances, we want to video and demonstrate the way it'll look when the clearances are proper. So I'll come right back to that. I'm going to assemble these 2. Washer goes against the bearing, and you should be able to pull down and spin with no friction. Then we get a plastic piece that slides onto there next. The plastic piece is the wheel spacer. It has the WHL for wheel and a small arrow that points down, that points towards the wheel. And the chamfer is on this end, while this end is flat. So the chamfer mates with the inner race of that bearing, and they're allowed to spin together when they're all touching. So from there, we'll just get the parts laid out. One of these for each wheel. And we're gonna, you'll need to put hardware in these. We'll need motors. So let's do these wheels first. Those are easy. And they're gonna use the same screws once again, but this time with hardware, with washers. So the washers of interest are M6 lock washer plus flat washer on each one. So these casters only have three screws on each caster plate. We go lock washer, then flat washer, then it's going to pass through, and then we're going to put the drop-in nut. And that's a set. Lock washer, flat washer, pass through, drop in nut. This will end up having a sensitive clearance where you need to clear the top of the screw for the caster to spin all the way around. And we're going to put 3 lock, then flat, then insert. Then we put a nut and at this point, you actually need to pay attention for a moment to where you're adding the screws because they're symmetric, they're not identical. I'll show you what I mean by holding it over the extrusion. So if this is the front and we're upside down now, then you can have screw, 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 and on this one, screw, screw, screw. So at this very moment, I could make the mistake of putting my screw in here, and it would match, it would be identical instead of symmetric. We want them symmetric, so that's the hole I do. You go screw, washer, flat washer, pass through, set the nut. Okay. Then we might have to backtrack slightly later, but if we get things fastened on, it keeps our kind of, your brain's able to see how stuff gets laid out. So I don't mind backtracking one step. We don't have to tighten things down deeply, just enough to hold steady again. We really treat tightening as one step at the end of everything. This is, if you could get this shot here, that'll show you how you may need to just push down just slightly so that nut can rotate like that. If I don't push down, or if I have things offset, then it will hang up instead of rotating, and you won't get the fastening force. So from there, it's just clamping more, but now the nut is seated right now. So that's good to go. Now, conditioning this will be an item. Let's get these motors ready. And you also need to pay attention to which motor. They are asymmetric, where both these wires will go to the motor driver. And if I'm sitting on Scuttle right now, then I'm pointing forward, where the right hand motor has a longer cable. So both of these will reach the motor driver. That's going to be on the left hand, the driver's side. So this is R. I'm going to actually, if you don't mind marking your motors, you can call this R, and L, and then so R is going to go here. Sorry, let's double check. This says L, so we're going to put it on this guy here. Then don't get confused and try to plan which hole. Out of these 6 threaded holes, we're only using 3, but you don't need to know ahead of time. You're just going to set it in there, and then you don't want your motor out like that. You're going to have it twisted almost touching because this shaft is offset. And as you rotate it, you're going to find the holes line up with your wheel bracket. Hold it with one hand and clamp. And then we need our M3 screws. The entire robot just has 6 units of M3 size screw. So you don't need to worry about how long it is or check the length, because the key point is, of all the fine screws here in this pile, The M3s are larger in diameter, and you can notice those. They're also countersunk. So I find, looks like 3, 6. I may have one extra, so we'll get initially assembled and notice if we have an extra on accident or if that goes somewhere else. This is my magnet bin. I strongly recommend a magnet bin. Has little magnets on the bottom so your stuff doesn't bounce away. Okay, and then before I actually thread them, I'll just double check. All right, these thread into the motor gearbox nicely, so that's gonna work. Double check, I had R and 1.5 R. You might have a new wheel bracket when you're watching this video, so it might not be 1.5, but it will retain the right and left designation, as this design is symmetric and not identical design, but symmetric design. And this, so now this screwdriver is too small. I could feel it right away. We want to be using a number 1 Phillips 1 for this. Usually this heavy kind of screwdriver is usually number 2, but I happen to have a different tip. You can feel there may be slight deviations in the hole where, okay, it doesn't drop in. This is a clearance hole by design, but it might have a little friction. You should just be able to tap it and it'll drop this thickness, 6.35 millimeters. So get that tightened. This one, if you're sure your quality of your wheel bracket's good, then you can tighten these all the way, and that will consist of finger force. In our instructions, we'll try to divide assembly of screw torque into either finger force or wrist force, and this is definitely a finger force. Everything you see here is finger force level of torque, not wrist force. So we'll go ahead and put the other in. Just check them to line up. You really just, if you're doing a placeholder and you're switching assemblies to work on a different area, you just need one and it'll be fastened. I'll put 3 in, even though we still have to check that wheel bracket. Oh, this is the part where I use my electric guy. Okay, these ones, strongly recommend. I think they're down around $25 now. They recharge with the USB cable, and honestly, the torque provided by this motor is just about what you need, and maybe just do a gentle turn after it stalls out, and don't turn it while you have the motor active. You could damage the motor. Okay, so we have now we get the positioning checked. This is the left hand wheel, which is driver's side, if you had a driver in your scuttle. And that means wheel will be outside here, and that means we don't want it up in the front, we want it near the back with a little extra space for a 90-degree bracket, that one. So as I assemble, I try to start positioning things to visually see what's the next step. This guy, I'll go ahead and try and finagle this. So this is, one way was sliding the nuts in after you've put the bracket on the extrusion. This way is put the nuts on the extrusion, on the wheel bracket, and then slide your extrusion in. So, and the tricky part is feeding those brackets in. I'm going to point it towards this camera so make sure it's actually showing for sure on that direction. And this one can be a hassle. I tend to do it the other way these days. And then the challenge is get that lined up so the slide in nut slides in. You might have to tighten the screw just a little to get the depth agreeing with the slot. Then that slides. Then the next one slides. Well, it looks like I lost a screw, so I'll just proceed and slide it in after. This is the assembly sequence this is part of the sequence that matters for you, for your convenience, because you don't want to already have these brackets on or all 4 channels, aluminum channels together when you need to adjust this or slide in one more nut. Did I drop the slide in nut on the floor? This is the drop in. I'll come back and grab that. It's pretty obvious when one of them is missing. So, all right. Now these motors won't point the same way. They'll point shaft out towards the wheel. So this one shaft is out towards the wheel. That means I need to slide the whole assembly back. Now, again, right hand has a long cable, left hand has a short. We can put together the rods assembly. I'm going to save this hardware. It's pretty obvious the M8 is larger than everything else, so it's okay. If you mix it up, it won't be hard to sort. Now, aluminum rods assembly. We hope to evolve this design from version 2.4. That's this assembly. Scuttle version 2.4 uses these aluminum tubes. They're 1/2 inch diameter. And it's good to treat these as one assembly with your brackets. Next version, we hope to have everything transitioned over to DIN rail. So this is the motor driver bracket. You'll notice it has places for 2 motor drivers, but the robot only has 1. That's just spare. And 2 of the 4 holes have their brass inserts. That's a threaded insert. Then if I'm on the driver's side, if I'm in the facing forward along with the robot, then this goes all the way down. Just enough to make the space for Raspberry Pi bracket. Or other CPU bracket is going to have the position for the circuit here, I2C board there. We're maybe more than midway through our assembly, so now is a good time to take inventory again if you haven't. Make sure that you didn't forget something. If you're not paying attention to the manual and you're free, going freestyle, then just looking at all your parts, taking a pause is a good way to notice if you forgot something. I'll put the 3 brackets here. So front of the robot, back of the robot, the battery bracket with no cells in it right now. It's going to have the terminals pointing to the back of the robot. Okay. Then the only thing you need to do is basically make these approximately level with each other. You don't want to make a parallelogram by having them offset. Then the 4 rod brackets. Rod brackets have a feature that slides into the extrusions. What I recommend for people is go ahead and put them on the rods, even though you'll need to take them off in a bit, to verify the orientation, because this, well, if we compare right to left, the gap points forward on this side, the gap points backward on this side, because these actually are identical rather than symmetric. That's to save the number of designs we issue and people have to keep track of. Then this is just for visual checking. We're sticking it on the rod to say which way, and you can slide them in this way maybe, or you can snap it. When you snap it, you should have a nicer sound than that, but sometimes it goes. You can feel it with your as you're pressing it. Should be able to be a strong finger force and just go in. Now, I do this on the rods to not get misoriented when I put the rod brackets on the extrusions. So that means the question I have is which way is it oriented and on which extrusion does it go and on which face. Bottom of the robot, right hand side rod bracket slides in, and this is going to take a little finagling again to get it started, and you might have a little dust of plastic from entering the aluminum, but that's okay. After this, the job of these feet is to always push outward and create friction so your rods don't slide around while you're driving. Front and back doesn't matter because they're identical, but you just have to get the orientation right. These prints, you shouldn't hear the little bits of cracking that I'm hearing, so that's not the best example. We have to double check the quality on these specific pieces. So that goes in, that goes in. What I see a lot, pretty frequently, is it can be tough for you to fit them in, and you don't want to put them backwards or on the wrong face. Depending on the sequence, this is where the sequence helps you a lot. Okay, what parts do we have left? We have these encoder brackets that we'll fasten the encoders to those. I think even before soldering the encoder, I'll go ahead and assemble the two. These come with a magnet each. Those are very special magnets that get sensed by the encoders. And I'm going to just put the boards on the robot now, and then I'll take them back off and solder them after we get 100% assembly, and then it's okay. Since it's so modular, most things you can remove without multiple steps. Keep things bagged if you can. These ones always bounce around and get stuck to some piece of metal, and then they can be hard to find. So these are identical, but the assembly is symmetric. They're both could be right or left, but you need to choose when you assemble this on there. So I'm going to position it over the shaft, because the shaft is where the motor pulley will get fastened. So here's how it goes. My two screws of size M2.4 countersunk. We look at this assembly. This version right now, 2.8, has the countersink feature with the countersink, a chamfered shape around the head. Countersink, not counterboard, but countersink. And then it's going to go like that. Before I tighten any of those down, I'll get the encoder put on. And key point for assembly direction is hold it there, and you know your connector is going to be in the front of the wheel assembly. So that means these header pin row will be in the front. Next, we find the screw that goes on there. I haven't poured it out yet, so maybe it's... I might have to grab those. Okay, in this case, we've made some changes on how we ship the small bags. We try to make it convenient, but sometimes there will be changes. I can go ahead and dump this, and I'll keep these separate. Okay, I2C circuit board and some small screws and the header pins. So the header pins are to be soldered. I'll set those aside. And then the small guys, these use Phillips 1 or 0 size screwdriver, and they're coarse threads with a pointy tip. That ultimately means you're going to get self-tapping performance. And with the self-tapping screw and a piece of 3D printed plastic, you don't want to assemble it a bunch of times. Removal and replacing many times will wear out that hole, but on the first time it should have a little friction, hold snug, and about requiring as much torque as this thing has. I'm letting off a little early. I can feel it twist when it clamps the board for sure. I can't wiggle the PCB with respect to the bracket. Then it's good. There's never any large forces on this assembly, so tightness is not necessary, but gap free is necessary. Grab the other one. Assemble these in pairs. Whatever you did for the right hand, you'll do the opposite for the left. And again, I can do something like put a little R here for myself. This is, you won't need it visible all the time, you just need it visible for if you move things around and then assemble it. That one's going to point that way, so symmetry, and I'll put a little L here. As long as you're drawing on something green on the PCB, you won't hurt anything on the circuit. When you use these ones, it's helpful to have a magnetic driver. Check your holes. There's only 2 holes in the design. And I don't tighten that one all the way. I leave it loose so the board can find its position when I add the second one. There's just a little clearance around the diameter of the screw, and we use that clearance to let the parts find their resting spot. Okay, so we'll go here, and I don't assemble it yet. This wheel assembly has to be finished first. Well, the wheel pulley. So motor pulley. It has a D shape on the shaft. That's going to line up with the D feature on your pulley, and this should be able to be pressed on with wrist force, and no more no less. This should be strong, and yeah, if you have 2 double finger force, maybe that's good. And it's going to stop when the shaft reaches this very small lip, small feature that creates a barrier. Then you're bottomed out on your shaft. You can see the shelf. We call it a shelf. The very small feature between the top portion and the shaft portion. And after we push that on, it's magnet time. So this is where we release the magnets. Your magnet will want to run around and find anything steel to clamp onto, like that. So we don't release the magnets till we're ready. We use a hex key is a really good tool to use, or the base of one of these. This is a 1/4 inch hex driver, and it fits nicely to keep this secure, and you have something to hold on to. We push that in, we drive the magnet into its position. It's going to be flush, or maybe slightly protruding, very small amount, but flush is, if it's flush or close, then you should be okay. This one we assemble onto the motor. I'm using my fingers just to lightly rotate that until I find the D position, maybe double check visually but you can kind of feel it seat before you push. This is the right amount of force, but the tolerance on these ones sometimes is hard to achieve, and if you have any defect, you want to catch that and get a replacement pulley, motor pulley. If it's like, if you need to use your pectorals to push this together, then you need to swap that out. Oh yeah, magnet time. I don't like to rip these bags. They're pretty strong and stretchy, and it's just one more chance for the magnet to jump out. I always keep a knife with me. And here we go, pressing in. You can feel it stop solid. Also, if the tolerance on these 3 grips is off, lucky thing is this magnet will stay linked to the end of the shaft just by attraction. Next, we still won't fasten that yet. Next is going to be this guy. So, conditioning, I might pause this video for boring those holes to precision before we continue filming. But let's do a quick tidy up. We'll talk over anything that's remaining. Hammer bracket. This is the wrench for the M8 nut. This is the stand. Tools in a row. Those, I believe, are just spares, but we'll double check. These are the remaining M3s. No, these are M2.4. These were the ones with the encoder bracket. Okay, something that appears to be spare, I'll just keep an eye out for. These small plastic things will go on Raspberry Pi or other header pins just to cover them. I'm going to set that aside. Checking my other cardboard boxes to make sure there's nothing. This is a charger. We have a couple variants of charger, so that's not part of the assembly. The gamepad and controller is not part of the assembly. So this is where I get all my cardboard. If it's empty, I stash it back there. This one's empty, so I can stash that. I'll close it all the way, and that's my reminder that it's been emptied out. This one, wiring, and motor driver. Yeah, that's going to go on the hardware assembly. We empty out the electronics box. SD card. Let's see what we got. Okay, this one can go on. This uses the same M2 coarse screws that I just had. Okay, there was spares. I almost bumped them. You can also use the electronic screwdriver. Get that on there. And I bring my circuit board, and then I find the holes, make sure they look like they'll be clear enough to accept the screw. It should grab on by itself because it's the self-tapping kind. I'm going to take a seat, get a little more steadiness. Sometimes even it's magnetic, I'll use just a fingertip to keep it clamped on my device. Oh, this is where also you need to check out for clearance. If we've applied the hot glue, that's a favor to help reduce chances of short circuit, but sometimes this hot glue might be a little bit thick. Then it's going to want to sit a little higher, so I'll correct that. I'll visually check. There's some words printed on the white letters. But it looks like I can just trim off of this. I don't want to give instructions with sharp objects, so I'm going to do this outside the frame. You could still film with that camera as a a takeout, but I don't want to tell people that they should use a knife like me. Basically, I'm just trimming off some of this hot glue that created a little interference, and I happen to know the area it fits, but you might have to do a little guessing and checking just to verify. If you put on your own hot glue and it's already hot when you assemble, it'll make sure that it's not too bulky. So I used this knife, but you have to be very careful and anchor everything on the table, like your wrists. Okay, the two holes in the top are indicating whether it's upside down or not. So that doesn't require instructions, but for version 2.3 it kind of did. And it looks like the top is still going to be a little, needs just a hair more trimmed off. And now I'm bumping into the, I think we're going to adjust this so that we don't send this with any hot glue. It's can be helpful, but it's also, there's a good chance of it interfering without any. The same person that adds the cover, the glue, ought to be the same person assembling, I think. All right, next anchored with the thumb. I think I can feed that in. I'm not tightening fully because I need a little bit of wiggle room. Okay, I2C brackets on. Now, motor driver. This is the 12 volt motor driver. Usually we often ship these and clip them first. I think that's worth learning, whether you need to do it on your kit or not. This is the part where grab safety glasses, because you'll fling some metal on occasion. Now we built this feature to have clearance for the pins that are on the bottom of the board. Oh, in this case, it really doesn't need trimming. But on the older bracket, occasionally you would have interference. So we would snip off the bottoms of these through hole connectors. And yeah, thanks cameraman. I deliberately pointed all the projectiles off to this side so you're not at risk. Those ones are short, they won't cause any interference. And you can feel that it's sitting flat. It's not raised up anywhere. So these are M2.5 with the flat head, not countersunk. So flat screw mates with a flat circuit board. It's all, it should be select your screws logically. If you have any lack of access to your diagrams or your guide, always, basically everything on this design has mates that mate with one another in agreement. You will not ever find a countersunk screw in a flat hole. So that just takes a gentle torque, so this can tolerate vibrating and stay secure. These ports, these screw terminals are going to take the wires, but that'll go on stage 2 video or something. I'm just verifying that things look good, there's clearance. Red and black. will go on minus and positive. We'll point that out in the wiring guide instead of in this video. Then, all right, what's left on our table? Let's set aside the tools. I can raise this just as a reminder of where it goes. So this is the rear extrusion, and that's the last thing to go on, I think. This is the front extrusion. We may have our end caps. Oh yeah, these are good to go on even if you want before you finish the full assembly. It'll keep your fingers a little safer from burrs. Now, if you have any, we're aiming to ship always caps that mate with a little force. If you have this gap, then we're going to use hot glue to secure them. I'll go ahead and grab really, this is a countermeasure that doesn't belong in the instructions. I think once we get 100% verified that the fitment agrees for all kits, this won't be a part. I'm really only including this in the instructions so that you have the ideas when you're working with extrusions in general. How else can you secure this besides taping or doing something difficult? This is Scuttle 652. Clamp that onto the wheel bracket on the top. Basically try to get all of our parts off the table. That's why we'll know when we're done, when everything's off the table. Now, wheels. Are we going to keep the cameras rolling? Give me a thumbs up if we're keeping the cameras rolling while I condition this stuff. Okay. We really are aiming not to ship anything that doesn't have the right clearance on this. So, once again, shouldn't be part of the standard process. The way I'm going to do this for this, I'll grab an extra. Okay. If you build your own wheel brackets, we undersize the design of this, then we drill it, and you want that to be very snug against your M8 screw, because if that's perfectly tight like this, maybe slightly less, you have the best chance of that robot surviving bumps while carrying a payload. You don't want it loose, just like a motorcycle helmet. So I passed the threads through a couple of times. It shouldn't take big muscles to push this in. It should be a finger force feel. So basically, I pass the threads through. It carries a little bit of plastic with it, and I brush off the threads. This is even, a custom fitment better than even the drill bit. We chose the smallest drill bit that still offers clearance, and every assembly that's 3D printed always will have a little deviation. Okay. Now this is spare, so I'm setting it aside to mix it up. Okay. Wheel assembly is ready to have the wheel go on. Make sure you know where your hardware, your M8 hardware is. It's going to be one flat, one lock, one nut. Then over here, you basically push the bolt / axle back to be basically flush with that. Hook your belt on your front pulley, and then pull back, and you're gonna want to just see the tip of the threads and find the hole. So basically this is a swinging motion until I find it while keeping tension. Then I And then I get, if you have a slight misalignment, it's going to add tension. You really shouldn't need more than the thumb. See, in this case, not the best example. That shouldn't require a heavy push. We're not gonna ship a part like that. So hammering is not okay. Tapping is okay. This is where we get into no-no territory if you don't have much experience with mechanical assembly. A tap like that is good. Twisting it will not do you any good. So, but we want this to honestly be finger force so that you know, you can feel when it's bottoming out. We have a defect on this one. It's showing a crack. So this whole item is going to be reprinted. On the back side, we do flat washer to spread the force on the plastic, lock washer to keep things secure during vibrations, and the nut. And this one, you always grab the small end of your hex key, and then you can use your scuttle wrench if you want to, and then twist that hex key while you close the gap. The gap present in the lock washer. Once that's closed, then you're going to notice it gets finger tight, and then you're good. This one's really falling apart. Okay. Now, same on this side. Where did it go? We tap that back. Hook the pulley, the belt, I mean. Hook the belt on the pulley. Then we're gonna refer you to the other video for this portion. This is not what you should deal with. No. See, this is a good example of why you go wrong when you start tapping things, or if this isn't addressed first. You need the nice, when your belt misaligns, now you're creating tension because the belt is trying to stretch further than it can. It's extremely, this belt will hold like 800 pounds, so it's not stretching at all, and instead it's pulling the two shafts towards each other. That puts stress on everything in ways that it's not supposed to be. And so you got to make sure your belt staying straight on throughout the assembly. That's why basically the friction in this hole is the key to everything going right. And if you don't have experience assembling this, it's so easy to just one time put a strong force where it's not supposed to go, and you'll have a bad day. Lock washer, flat washer, flat first, and lock, and the nut. We're going to check up top, make sure our other washer is still there. Okay, and when we get all this said and done, we're going to see that the belt should be perfectly flush with the face of that. And you should have equal friction. You should feel the gears of the motor and the motor spinning at high RPMs. If you're actually touching this shaft, you can feel it spinning at a very high speed because that's a gear reducer. Then we go back to the right tightness. Honestly, I'll just demonstrate here. You don't even need the wrench because the torque coming from this end is easy to counteract, and once it gets tight enough that I can't grasp it, it's already been tightened enough. So we go right side up on everything. Check fitment. We're gonna do our or hot glue sequence. This component has little slots on the sides that the glue will protrude from, and then you just find it, make sure it's flush, and then let the glue cool. It's secure, but still removable when you need to. So orientation doesn't matter as long as you go 90-degree increments. And you can always remember that the front and back extrusions are the ones that have a plastic cap, because the right and left extrusions are mating with the front and back instead of having any end cap. Okay, so there's that. Now, parts check. These can go on. We're going to verify that you get 1 millimeter clearance between that magnet and this sensor once you assemble. And we don't need to give a shot of that, because I'm not so confident that this one's in a good condition right now. But the magnet should be not touching and have a small clearance to your sensor. And since the sensor is the tallest feature on this assembly, in regards to that sensor bracket, and if it has clearance, everything has clearance. Okay. We had a team member mention that these ought to go to a design with flat screw instead of countersink, because the countersink wants to split the 3D prints, and that is a very valid point. The decision at this variation was made in order to reduce the variety of screws in the kits, make these just simpler and make identification foolproof. Because currently with version 2.4, I think that was a slip, an incorrect kit where they put the M3 instead of M2.5. So we'll pretend I already put that screw in, and each wheel assembly looks like that, only these will be soldered already. Okay, now I like to put the rods in first before I put the front and back on. So now we pretend the whole thing's upside down. That's nice. Gravity, we have a basically balanced assembly on each side. Now you can basically, this is going to tell you where to space your rod brackets. So you could put them a little bit close, get this snapped in. Okay. Come on. These 3D prints need an overhaul in this kit. Then you can slide the front one up and the reverse for this other side. So I'm going to snap that in. That's a nice solid snap. I'm going to slide that guy back, and then that one's also going to snap in, but we'll probably just split the print instead. Okay, now things are crooked with one another, so we can slide this pair all the way back to touching, slide this pair all the way back to touching, and then we'll do front placement of the front extrusion such that we have the clearance. Okay, so we have clearance. Oh man, I put this backwards. We're gonna have to flip all these brackets once we get it right set up. not for the video. Okay, in this case, what I usually do is I choose to, you don't want to have to make all the drop-in nuts find their way in at the same time. So one way is we go ahead and remove the caster again, but keep track of right and left. Once those are loose, you can just shake its way out. We get this item in, and then okay, so I want to be able to push this with my thumb. I loosen just a hair, loosen this just a hair, push that, and we're going to have to do this from the top side or use a longer screwdriver. If you thread that many times, yeah, okay. Don't worry about everything being aligned at the first go. You want to align stuff perfectly after you get all the brackets together. All the fasteners are in the robot, then all the fasteners get tightened. That is the best, easy way. Okay, now the rear, oh, I forget. Casters can go on at any time. Camera can go on at the very end. This guy can go on as a swap situation. I'll show that. And we have a screw. Instead of having washers on these screws, we chose screws that have a large, oversized head compared with most M6. That is why these don't need washers. You can set that aside. Yep. Don't get frustrated when all the screws want to slide around on you. The alternative to this, to having things slide a lot during assembly, is that these are not drop-in nuts, and they're nuts that require you to have them all in the right slots, in the right positions before you start, which if you do this a couple of times, you'll for sure get part of the assembly out of order, and you'll be thankful that these are drop-in nuts. Okay, so now what do we have left? We can go ahead with this. So 1, 2, 3, get it onto that side. 1, 2, 3, get it on this side. And this is literally the best way, is just kind of jiggling it in, because you want those all the 3 screws to fall down by gravity before you do any tightening. And I do a twist or two of loosening. I have to take a peek and make sure that the drop-in nut got aligned. So this one didn't want to rotate, so I'm going to back it off until it descends just a bit, and now it's retightening. Back it off and then retighten. And I can see, from my perspective, I can see that it rotated into its position. These ones, yeah, so we can tighten quite a bit more than this at the very end. You want to leave room. So like, see, this one's not dropping in. So what we're going to do, just shake things until they get there, find their spot. I'll make sure this one's still rolling. Locked up. Does that mean it's not rolling anymore? Storage full. Oh, okay. Well, now we know we shouldn't have done 4K. It's all you. All right. Get that tightened. I saw this one rotate. See, all these are good. In some designs, we actually only put 2 screws caddy corner. So like this is more than enough M6 hardware to hold things secure. If one of them causes you a lot of trouble, you can probably leave it out. Just use your common sense on, or if you're gonna put a heavy payload. Okay, at this point, we gotta make sure the wheel brackets come all the way back to that aluminum before you tighten. Again, it's wrist tight, a gentle wrist tight on these and against the plastic. And you can do all the wrist you want on these ones, on the corners. It really, if I'm ready to run a demo with something heavy on the robot, that's when I go and give it a strong torque on all 8 of these for sure, and the 6 on the bottom of the casters. Okay, as you can see here now, I got all my brackets reversed, so I'll fix that. Motor driver on the left, CPU in the middle, battery on the right. Wasn't that easy? Okay. Label right there. Stand for testing the wheels. Cables, we'll put in a second shot. Camera. This is upside down. If you continued in this way, you actually want to do that. You take the twist bracket and point the gap to the back. So then you point, gap goes pointing to the front. It's either you put it right or you put it 180 degrees from right. And this is right. If you want the camera in the back, it goes there. We're gonna assemble this one on a second shot where we put, basically this is the 12mm length M6 screw, and we're gonna replace that with a 16mm because we're adding, or maybe it's a 14mm. We add some thickness to allow the screw to pass through this arm, and still make it into the nut that's inside that extrusion. So those ones have a longer screw. I think we're, oh, this is what the screw looks like. Hold on. So if you compare the two, you'll have 2 screws that are extra long, and those are just for if you're using this adapter, or we would probably use a different adapter if you have any of the more advanced boards that take more power than the Raspberry Pi. Raspberry Pi can operate off a regular USB, and SD card's gonna go what's that? See the side. That goes away. Tool Don't lose your tools. Cable is here. These ones have an explanation. This one, the explanation is it belonged here if you're not adding the bracket. The two remaining header pin rows go in the encoders. These screws are going to go in your Raspberry Pi or other the other designs for CPUs have M2.5 screws as well. This one was actually extra. It's going to be there.